Hello, welcome to the course of computer network. So today we are going to discuss about the internet protocols. So as in previous lecture we have discussed about the ARP and RARP internet protocol. Now we are going to discuss about ICMP, NDP, DHCP and NAT protocol. So starting with the very first, let's discuss about the ICMP. So ICMP stands for Internet Control Message Protocol and it is used to provide device the information about the network problem. So here the ICMP is used by network devices like routers to send error messages and operational information. ICMP servers execute on all IP and system computers and all IP intermediate system. So here the difference between the ICMP and other transport protocols such as TCP and UDP is that it is not used for exchanging data between the system and network. Here, the ICMP protocol is used to report problems with delivery of IP packets within an IP network, like when a particular end system is not responding, when an IP network is not reachable, when a node is overloaded, and when error occur in IP header information. So these are the problems that are suggested by ICMP protocol, or it is this protocol report the problem to the device. Here the ICMP protocol is used by an internet manager to verify correct operation of AND system, and it also checks that routers are correctly routing packet to the specified destination. So here the ICMP functions are announcement of network error or the network congestion, assisting troubleshooting using traceroute or ping message, and announcing timeouts of the packets. So this is the ICMP packet format. Here the ICMP header starts after the IPv4 header. ICMP packet have a 8-byte header and variable size data session. So the first is ICMP type. Here this type field indicate the type of the ICMP packet. And this is always different from the ICMP type to type, and this field is of 8-bit long. Next is ICMP code. Here all ICMP type have different code. Some type only have a single code while other have several code. So this field is also of 8-bit in length. Next is checksum. Here this checksum is a 16-bit field and it is used for error checking of the header field and the data. And last one is ICMP content. This field have variable size and it contains the user data. Next is NDP, that is Neighbor Discovery Protocol. So this protocol is used with IPv6, that is Internet Protocol version 6. It operates at the link layer of the Internet model and it is defined in RFC 1122. So it is responsible for collecting information required for Internet communication, including the configuration of local connection and the domain name servers and the gateway. So here the NDP performs functions similar to ARP and ICMP of IPv4. Here the inverse neighbor discovery protocol extension is also defined under RFC 3122, and here it allow nodes to determine and advertise an IPv6 address corresponding to the given link layer address or the MAC layer address, similar to RARP protocol. So it means the NDP works similar to ARP and ICMP, whereas INDP works similar to the reverse address resolution protocol. Next is DHCP, that is Dynamic Host Configuration Protocol. It is a client server protocol and it automatically provides an internet protocol device with its IP address and other related configuration information such as the subnet mask and default gateway. So it is defined by IETF under RFC 2131 and 2132 based on the Bootstrap protocol, that is BootP. Here this is a DHCP message format. So it starts with the very first field, that is operation code. So here the message operation code, it sets to 1 for the boot request and it sets to 2 for the boot reply. Next is hardware type. Here the hardware address type, it indicates 1 for the 10 MB Ethernet, and next field is hardware address length. Here this is set to 6 for the 10 MB Ethernet. Next is hop. Here the hops that is set by the client to 0 and it is optionally used by relay agent when booting via relay agent. Next is the transaction identifier. Here the transaction identifier, it is a random number chosen by the client and it is used by the client and server to associate the request message with its response. Next is the seconds. Here the seconds passed since client begins the request process. So this field is also filled by the client. Next one is flag. This indicates the flag. And another one is the client IP address. Here the client IP address is filled by the client and it is filled by the client if it knows its IP address by using the ARP request. Next is the yours IP address or the client IP address. This is filled by the server, or this is a server response to the client. Next is the server IP address. Here the address of sending server or of the next server to be used in the next bootstrap process is used. Another one is gateway IP address. Here the gateway IP address is also known as relay agent IP address and it is used in booting via relay agent. Next is the client hardware address. Here the client hardware address is of 16-bit and it defines the MAC address of the client. Next is server name. Here this is an optional field and it contains the server host name. Next is the another one is the boot file name. Here the boot file name, this field will contain the name of the file for the booting process and it is of 128-bit long. Next the last one field is option and this is a optional field and it contains the variable size. So this is about the DHCP message format. The another one we are going to discuss about the NAT, that is Network Address Translation Protocol. Here the NAT stands for Network Address Translation or Network Address Translator. Here this translator in the process where a network device like the firewall assign a public address to the computer inside a private network. So it is a virtualization of the internet protocol address and this helps in improving security and it also decreases the need of large number of IP addresses in an organization. So here in NAT the private address range is used, that is 10.0.0.0 to 10.255.255.255. This is the class A address. Class B is 172.16.0.0 to 172.31.255.255 and the class C address are like 192.168.0.0 to 192.168.255.255. So these are the private address ranges of class A, class B and class C. So this diagram is showing how the NAT process works. Here the NAT technique works well for computer that only have to access resources inside the network or the organization. For example, here the host want to access file server and the printer. So here these computers that are assigned in a particular network, these can access the resources from each other and all, like from the printer or the file server. Here to use their resources, they install the private address router inside the private network which can route the traffic between the private address with no trouble. So these are using the private address router to route the network and between the private network. So if a host want to access the resources outside the network from the internet, then the host must contain the public IP address. So like if this computer wants to access any resource from outside the network, then it must have a public address. For that, what this NAT process use, they use the NAT router from on which it's one port it contains the private IP address and on the another port it contains the public IP address. And by using this public IP address, it communicates to the outside network. And the outside network computer only knows this network from this public IP address and they are not using this private IP address to communicate with any other external network. So in this way, these private IP address will remain confidential and only this public IP address will reveal to this internet or the external network. So in this way the NAT process work. So this is all about the internet protocol. Thank you.